as food is important to humans, and alphabet and words form the basics of English language, so also numbers form the basics of mathematics and are important to mathematicians. Whatever you are doing in mathematics, it is either you are adding, subtracting, multiplying, or dividing numbers. Hello viewers, welcome to my channel. My name is Michael Warren, a primary level medical student at the University of Benin. In this video lesson, we are going to look at numbers under the following headings. Before we do that, we have to understand what numbers are, or the definition of numbers. Numbers are mathematical values or quantities that are used for counting, measuring, or labeling, or ordering. By counting, what do we mean? We have a word on the board which is numbers. We can count the number of alphabets present. By counting, we have 1, 2, 3, 4, 5, 6, 7. So in the word numbers, we have 7 alphabets. So 7 has helped us, or has helped us to count the number of alphabets present in the word numbers. Also, we can use numbers to measure. I can take a tape and measure the length of this board and tell that the length of the board is 7 centimeter or 7 meter, or as the case may be. So I can also measure a football field and tell that the length of the football field is 120 meters. So that is the importance of number in measuring. And lastly, we can use numbers to label or order. By labeling or ordering, what do we mean? We have 3 students in a class, and let's assume after the performance or after the conduct of the test, this first student got 70%, the second student got 50%, and the last got 30%. We can place this student in a given order by saying this student got 4th position, this student got 2nd, and this student got 3rd. So these numbers have helped us to label the student or order this student. So we move on to look at the first subtopic, which is the decimal place value system. In a family, everyone has a particular role or a place in that family. We have the father, mother, and the children. Even among the children, we have the first child, second, third, down to the last child. So it is with numbers. When we are given numbers, we have various numbers within it. Each of these numbers is called a digit. So we have what is called a digit. So 6 here is a digit, 8 is a digit, 3 is a digit. But when we look at these digits, they have a particular place value within this number. So we're going to look at the place value of each of this number. Now, when we are given a decimal number, such as there's a decimal point, this point is called the decimal point. Decimal point. From our decimal point towards the left, we have the whole numbers. While from our decimal point towards the right, we have the decimal numbers. So let's look at the place values of each of these digits. So immediately towards the left, just from your decimal point, the first place value here is called the unit. Moving on, you have tens. Then moving on, we have 100. Then moving on, after 100, we have 1,000. Then after 1,000, we have tens of thousands. Then moving on, we have 100 of thousands. Then we have, after 100,000, we have millions. This place value can also proceed towards billions and then on and on. Remember, from our decimal point towards the left, we have our whole numbers, and from our decimal point towards the right, we have decimal numbers. Now, each of these decimal numbers have a place value just like the whole numbers. The first digit just after decimal point is called the tenth. Tenth. We don't have a unit, but we have a tenth. Then the second is called the hundredth. Then next, I've just like 10, 100, we have 1,000 with a 1,000. So it's interesting to know the place value of each digit within a number. So let's just go over it again. We have our decimal points. From our decimal point towards the left, we have our whole numbers, and each of these digits have a particular place value. So we have the unit, the tens, the hundred, the thousand, the 10,000, the 100,000, and then million. It can even extend up to billions. Then from our decimal point towards the right, we have our decimal numbers. And the place value is, for the first one is the tenth, we have the 100, we have the 1,000, and we have the 10,000. So move on to look at the second subtopic, which is natural numbers. Now, what are natural numbers? Natural numbers are simply a basic set of numbers, or we can say they are our positive set of numbers. So our positive set of numbers start from 1, 2, 3, down to infinity. So our natural numbers include 1, 2, 3, 4, 5, down to infinity, continues, so on and what, so forth. So in mathematics, natural numbers are represented, or they are denoted with a symbol called n. So anytime I see n in mathematics, it means the natural numbers. So I am giving this representation such as x is a member of the natural numbers. This means x, this symbol means it's a member of mathematics, it's a member of the natural number. It means x can be 1, 2, 3, 4, 5, 6, even 100, 1,000, 1,000,000. That is a natural number. And one thing you should know is that 0 is not a natural number. Remember, we said our natural numbers are positive numbers. Positive. 0 is neither positive nor negative. So remove 0. So our natural numbers are from 1 down to infinity. So move on to look at the third subtopic, which are integers. Now, what are integers? Integers are both negative and positive natural numbers. Remember, excluding 0. 0 is not an integer, just like 0 is not a natural number. So for integers, you can have -3, -2, -1. Remember, there's no 0, so the next will be 1, 2, 3. So you can continue to both sides. They can continue to both sides. So in mathematics, integers are represented with z or z. So in mathematics, we could have a mathematical representation which is that x is a member of the integer. Remember, x, this symbol in mathematics means is a member of, then this is integers. So if they tell that x is a member of the integers, it can be a negative number or a positive number. But if they tell that x is a member of the natural number, we expect that it is a positive number. So these are negative integers and these are positive integers. Remember, they can extend to both directions. We can have 4, 5, 6, 100, 200. On this, I can have -100, -200, -1,000. So move on to look at the fourth concept, which are factors and multiples. So let's look at factors. What are factors? Factors are simply numbers that can divide another number without a remainder. For example, let's do a simple number. Let's deal with 6. Let's deal with 6, 6, 6, 6. Let's do 6 in 6 places. Let's divide it by 1. Divide this one by 2. Divide this by 3. Divide this by 4. Divide this by 5. And divide this by 6. Now, 6 divided by 1. This will give us 6. We have 6 on this side. So for this other one, 6 divided by 2 will give us 3. So we have 3. So for the next one, 6 divided by 3 will give us 2. So we have 2 on this aspect. Then for the next one, 6 divided by 4 will give us 1 remainder 2. So I'll write that remainder here. 1 remainder 2. So for the next one, 6 divided by 5, we are going to have 1 remainder 1. So for this, we have 1 remainder 1. Then for the next one, 6 divided by 6, we are going to have 1. So now, if you look at this 4, 1, 2, 3, and the last one. Each of them, 1, 2, 3, and 6, they can divide 6 without remainder. So in mathematics, we call this set of numbers factors. But for 4 and 5, when they divide 6, they produce a remainder. So hence, this is not a factor of 6. And this is not a factor of 6. So hence, you can see that the factors of 6 are 1, 2, 3, and 6. Why? The reason is simple, because each of these numbers can divide 6 without a remainder. So if I'm giving a number 40 and I'm being asked if 8 is a remainder, if 8 is a factor, 8 can divide 40 and that will give us 5. There's no remainder in this case. When I'm giving a number such as 16 and attempt to divide 16 by 5, or I'm being asked if 5 is a factor of 16, 6 divided by 5 will give us 3 remainder 1. Because there's a remainder, 5 is not a factor of 16. So the next thing we look at is multiple. What are multiples? Multiples are just the reverse of factor. Remember in the previous part, we said that 1, 2, 3, and 6 are factors of 6. So in the reverse case, 6 is a multiple of 1, 6 is a multiple of 2, 6 is a multiple of 3, and 6 is a multiple of 6. So it's just like from the word multiplication. So another way we can define multiple are numbers we get by multiplying two things. So now look at something. When we're in kindergarten, in primary school, we're always reciting the 2 times table, 3 times table, down to the 12 times table. So let's look at the 2 times table. So in 2 times table, we have 2 times 1 give us 2, 2 times 2 give us 4, then 2 times 2 give us 6. You can go on and on. Now these numbers 2, 4, 6, you can have 8, 10, 12, 14. All these numbers, they are multiples of what? 2. You understand now? For a 3 times 2, we are going to have 3 times 1, 3, 3 times 2, 6, 3 times 3, 9. So each of these numbers we get by multiplication 3, 6, and 9. They are all multiples of 3. So we move on to look at prime numbers and prime factors. Now what are prime numbers? Prime numbers are simply numbers that have just 2 factors. And those 2 factors are 1 and itself. So they have 2 factors, which are 1 and itself. So these are the only 2 factors of such numbers. It means 1 can divide that number without a remainder, and itself can also divide that number without a remainder. After that, there's no other number that can divide that number. Meaning it has only 2 numbers that can divide it without a remainder, which are 1 and itself. For example, look at 2. 2. 1 can divide 2, yes. This will give us 2. Then itself, which is 2, can divide 2 to give us 1. There's no other number that can divide this to give us another number. If you try 2 divided by 2, we are going to be having 0 point something. For prime numbers, they have only 2 numbers that can divide them without a remainder. Just 2. For example, let's look at 5. This is 5. 1 can divide 5 to give us 5. Itself, which is 5, can also divide it to give us 1. If you use any other number, you have a remainder. For example, let's say 5 divided by 2. This give us 2 remainder 1. If you try 3, 5 divided by 3, this will give us 1 remainder 2. If you try another number, you keep having remainder, or some might not even divide it. Now we are having 0 point something. If you try having 5 divided by 6, you'll be having about 0 point with some decimals. So this number of 5 only have 2 factors that can divide without a remainder, which are 1 and 0. Before we move on to prime factors, let's quickly do something. Just to add, 1 is not a prime number. So 1 is not a prime number. Anyway, any day in mathematics, 1 is never a prime number. So if you look at 2, just numbers can divide 2 without a remainder, which is 1 and 2. So hence 2 is a prime number. So this is a prime number. 3, just 1 and 3 can divide 3. There's no number that can divide 3 to give us a whole number. So 3 is a prime number. Now looking at 4, 1 can divide 4, that's fine. It said 4 can also divide 4 to give us a number. To give us a whole number, that's fine. But there's another number outside 1 and 2, which is 2. 2 can divide 4. So we now have 3 factors. Hence, 4 is not a prime number because outside 1 and 4, another number which is 2 can divide 4. For 5, just 1 and 5 can divide 5. So hence, 5 is a prime number. Now moving on to 6, 1 can divide 6. It said which is 6 can also divide 6. But two other numbers can divide 6 without a number, which are 2 can divide 6. 3 can also divide 6. Hence, 3 is not a prime number. Moving on to 7, just numbers can divide 7, which are 1 and 7. So hence, 7 is a prime number. Now, for 8, 1 can divide 8. It said 8 can divide 8, but 2 can divide 8. 4 can divide 8. Hence, 8 is not a prime number. Now, for 9, 1 can divide 9. It said 9 can also divide 9. But 3 can divide 9. Because of that, 9 is not a prime number. So also for 10, 2 and 5 can divide 10. So 10 is not a prime number. So you can check out all the prime numbers you have from 1 to 100 down to 1000. The big thing is that a prime number has only 2 factors, or 2 numbers that are divided without a number, which are 1 and itself. So before we move on, let's look at prime factors. Since we already know what the prime numbers are. Prime factors are simply factors of a number that are prime, meaning they are factors that have only 2 numbers that can divide them. Now look at this example. 1, 2, 3, and 6. They are factors of 6. You know why they are factors? Because these numbers can divide 6 without a remainder. Now when we look at these factors, we will find out that some are prime and some are not prime. So now 1, remember 1 is not a prime number, so you can exclude this guy. Now 2 is a prime number, 3 is a prime number, but 6 is not a prime number. So hence, they are factors, but just these 2 guys are prime factors. 1, 2, 3, and 6, they are all factors, but 2 and 3 are prime factors. So hence, you can therefore see that 2 and 3 are prime factors of 6. Are prime factors of 6. Remember, 2 and 3, they only have 2 numbers that can divide them without a remainder. Those numbers are 1 and itself. So move on to look at the next subtopic, which is fractional numbers. Now, fractional numbers can also be called fractions. Now, what are fractions or what are fractional numbers? Fractional numbers are numbers in which they exist as a ratio between 2 integers. So, fractions is simply a ratio between 2 integers. Ratio simply means division. Remember, we talk about integers. Integers are either positive numbers, positive whole numbers, or negative whole numbers. So let's really add something. Natural numbers and integers, they are whole numbers. Whole numbers. Whole numbers. So remember, natural numbers are positive whole numbers, while integers include both the negative and positive whole numbers, excluding 0. So coming back to fractional numbers. Fractional numbers are ratio. Ratio simply means division between 2 integers. So we have an integer a over b. This is the ratio between 2 integers. So we call this one above, we call it the numerator. The numerator. The numerator. Then we call this one the dividing line. The dividing line. And dividing line. And then we call this the denominator. Denominator. So in essence, what we have above is called numerator. What we have below is called the denominator. So in mathematics, we have several types of fraction. So we can have a case where the numerator is smaller than the denominator. We call this guy a proper fraction. Just imagine your father placed you on his shoulder, is carrying you on his shoulder, is proper. You are above, you are smaller than your father. So that's a proper scenario. So we call this type of fraction a proper fraction. Proper fraction. Because this child is above, then the father is under, or in mathematics, the numerator is smaller than the denominator, or the denominator is bigger than the numerator. So for an improper fraction, just imagine you try to carry the father on your neck. That's improper. So in this case, the numerator, the child, is under, then the father is above. So in this case, in mathematics, we say the numerator is bigger than the denominator, or the denominator is smaller than the numerator. So we call this type of fraction improper fraction. So in the last type of fraction, we have a case where we have a whole number. This too is a whole number with a fraction. We call this type of fraction a mixed fraction. So it's made up of a whole number, in this case 2, and a fraction. So we call this type of fraction a mixed fraction. A mixed fraction. So proper fraction, improper fraction, and then mixed fraction. So move on to look at rational and irrational numbers. What are rational numbers? Rational numbers are numbers that are expressed as ratio of two integers. Remember, fractions are ratio of two integers. So in essence, fractions are rational numbers. So in this first case, 2/5 is a rational number because it is a ratio of two integers, 2 and 5. 5/2 is a rational number. So basically, fractions are rational numbers. Next, rational numbers can also be numbers that have a terminating decimal. Terminating means an end. 0.5. For example, if you take your calculator and press 1/2 or 1 divided by 2, you have 0.5. It has an end. So such numbers, we call them rational numbers. Also, rational numbers are numbers that have repeating decimals. Repeating decimals. If you take your calculator and press 10 divided by 3, you're going to have 3.33333. So it has a repeating decimal. So all these categories of numbers, rational numbers. So remember, they are ratio of two integers, which are fractions, or they are numbers with a terminating decimal, or they are numbers with a repeating decimal. Now, when we look at irrational numbers, they are numbers that have non-terminating and also non-repeating decimals. Means they don't have an end, and decimal they don't repeat themselves. For example, in this case, they repeat themselves. 3 it is repeating. But in case of irrational, they don't repeat themselves. For example, root 2, which is a solid, if you press you add by 1.414, you will see that the number they don't repeat themselves. Such as this will give you about 1.414, so on and so forth. 4 and 1 they are not the same, unlike 3 that are the same. Also, pi, which is 22/7, is an irrational number. Then the Euler's number, this is the Euler's number. So this category of number, we call them irrational numbers. So we move on to look at real numbers. Real is just like the word reality. In reality, we have both positive numbers, negative numbers. Numbers exist as fractions, exist as rational and irrational numbers. What about real numbers? Real numbers include our positive integers. They include our negative integers. They include our rational numbers. They include our irrational numbers. Then they include our fractions. So they all make up our real numbers. So rational numbers and then irrational numbers. So we can have positive integers such as a plus 2, negative integers such as -2, rational numbers such as 2/5 or 0.5. We can have rational numbers such as √2, then fraction 5/2, 2/7. So they all make up real numbers. So we move on to look at the last subtopic, which is binary numbers. But before we do that, let's quickly understand something. In life, there are so many number systems. We have what we call the Roman numeral, it's a number system. We have what we call the decimal number system. And this decimal number system is commonly used by humans. For example, our number ranges from 0 to 9. That's we have 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Any number we can think of must take digits from 0 to 9. When we talk about 910. 910, they are within this decimal number system. So this number system is commonly used by humans. Then for binary number system, commonly used by computers and other computer devices. Binary is from the word buy, buy, and buy, just like you have the word bicycle, 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 buy means two. Then cycle just like the tires or the wheels of it. So that has two wheels. So the same thing with binary. Binary, like you have the word decimal, like the word decagon, dec means 10. So in the decimal numbers for humans, you have 10 digits. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's why it's called a decimal number system because they are just 10 digits. But for the binary, it is bad because they are just 2 digits. And those 2 digits are what? 0 and 1. So I don't expect to find 2 in the binary number system. I don't expect to find 9 in the binary number system. So it's called a binary because there are just 2 digits present in this number system. So what are we going to do when we want to match a number in base 2 to a number in base 10? First of all, we are going to multiply each of these digits by 2. So we are going to say 1 times 2 plus the next digit is 0. 0 times the base, which is 2. 0 times 2 plus the next number is 1. 1 times 2. So remember, multiply each of the digits, no matter how long it is. Multiply each of the digits by the base, each of the digits by the base. Then when you have done this, you see the base 2, 2, 2. You are going to give them powers from 0 to wherever you can get up to. But you are going to start from the right down to the left. So you are going to give each of these base powers starting from 0. So I'll start from power 0, power 1, and then power 2. So when you have done this, you can easily add 2 raised to power 2 means 2 times 2. And 2 times 2 will give us 4. 4 times 1 will give us 4. So this is 4 plus 2 raised to power 1. In mathematics, anything raised to power 1 is itself. So if I have x raised to power 1, it is x. 3 raised to power 1, it is 3. 10 raised to power 1, it is 10. So in this case, 2 raised to power 1 is 2. And 2 times 0 is 0. Plus, now 2 raised to power 0. Most students will tell us that 2 raised to power 0 is 0, but that's not true. In mathematics, anything, I mean anything, raised to the power of 0 is 1. So if we have 2 raised to the power of 0, it is 1. X raised to the power of 0, it is 1. If we have x raised to the power of 0, it is 1. So hence 2 raised to the power of 0 is 1. 1 times 1 will give us 1. So when we add up 4 plus 0 plus 1 will give us 5 in base 10. So our final answer becomes 5 in base 10. So in question 2, we have to convert 5 in base 10 to number in base 2. So when we are converting a number from base 10 to base 2, we are going to do what we call a continuous repetitive division. Unlike this case where we multiplying continuously, when we are going to be dividing continuously because it is the reverse of this other one. So we have a number in base 10, which is 5. We are converting it to base 2. Hence, we are going to divide with 2. We are going to divide continuously with 2. Now, when 2 divides 5, 2 can divide 5 2 times with the remainder of 1. So this will become 2 remainder 1. Next, we divide again because it is a continuous division. 2. Next, 2 can divide 2 once without remainder. So that becomes 1 remainder 0. Next, we go again. 2. 2 cannot divide 1. It is not possible in this case. So this becomes 0. Since it did not divide 1, it will be remainder 1. So 2 cannot divide 1 because 2 is bigger than 1. So in this case, it is not possible. So it's 0 remainder. Because it did not divide 1, so it becomes remainder 1 because we didn't touch it. So your division in binary will always end in 0 remainder 1. So when you have done this, you are going to read up your values. So you are going to read up the values. Read them up. So you are going to read as 1, 0, 1. So therefore, 5 in base 10 is equal to 1, 0, 1, not 101, but this is binary number. So you want 1 whole 1 in base 2. So we have some exercises, and the first one says we should stay in simplest set to which each of these numbers belong. So we have -5. -5 is a negative whole number, and negative whole number and positive whole numbers form part of integers, while natural numbers are only positive whole numbers. So hence, because this is a negative integer or a negative whole number, we can call it an integer. So remember, integers are represented with z, while natural numbers are represented with n. So next we have 2/2/3. This is a ratio between two integers. So we can call this a fractional number. And remember, fractional numbers are also rational numbers. So we can call the fractional number or a rational number. Next, we have root 11. Root 11 will give us a repeating and a non-terminating set of decimals, rather a non-repeating and a non-terminating set of decimals. So this becomes, remember, non-repeating and non-terminating set of numbers are irrational numbers. So this becomes an irrational number. The 1.86 is a terminating number. So because it's terminating, remember, rational numbers are terminating and repeating numbers. So this is a terminating number. So this is a rational number. Terminating because it has an n. Rational. So in question 2, we have to combine each of these fractions. So when we fraction, this is a very easy thing to do. So we have 0.5. We want to convert a decimal number to a fraction. What do? We are going to move our decimal point to the last number. So move it to the last number, which is 5. When you do this, the natural number here is 5 over, you add a 1. How many times we move the decimal point? Just 1. So it becomes 5 over 10. If I move it 2 times, I will have added 2 zeros. So we can divide the fraction now. So when 5 divided by 5, it gives us 1. And 5 divided by 10 will give us 2. So our answer becomes 1 over 2. So 0.5 is the same thing as 5 over 10, and same thing as 1 over 2. So also in fraction, when two fractions have the same value, we call those set of value equivalent fraction. Equivalent fraction. Equivalent fraction. For example, 1 over 2, 1 over 2, 5 over 10, and then let's say 3 over 6. This fraction, we all call them equivalent fraction. Because 5 divided by 5 is 1, 5 divided by 10, 2, 3 divided by 3, 1, 3 divided by 6, 2. So they have the same value of 1 over 2, 1 over 2, 1 over 2. So that's how we convert this. Now for the B part of it, 3045, we are going to combine two fractions. So move our decimal point 1 to the last number 2 and then 3. So it becomes 3045 over add the 1. We move our decimal point 3 times. So I'm going to add 3, 0, 1, 2, 3. So next we are going to divide this. When we divide this by 5, we are going to have 609. When we divide it by 5, we are going to add 200. So our answer becomes 609 over 200. So viewers, I hope you learned something from this video. Be sure to subscribe to this channel so that you always get notified as soon as new video to drop. And don't forget to share these valuable video lessons with your friends so that we can all learn together and support one another on this academic journey. I look forward to seeing you in my next